Restrictions on functions. So certain functions are given with restrictions on the domain and range, or on the domain, sorry. Consider, for example, the following function. So you're given f of x is equals to x squared with something next to it there, the restriction. They're telling you that x is bigger or equal to 0. Now, if you forget about this for now, and draw f of x equal to x squared, you're going to get that the function looks something like this, where it turns on 0 is to 0 there. Now if we consider that thing next to the equation, that is x is bigger, that part, that is x is bigger than or equal to 0. It says we only consider the x's that are 0 or bigger, so we only look at that side. That means that we don't consider this part. So our function will only be on this side. That's what the restriction does. It just cancels one side of the parabola and focuses on the other. Let's continue and see how this works as well. Now, when applying transformations, that is when you want to find the inverse or the reflection to a restricted function, always write down the domain as well as the range of the function, the original function. So in any transformation must be applied to the function formula as well as the domain and range. So apply all of these things to both the domain and range, and not just the function. So this will be easier to do if you write both the domain and range as inequalities. So it's easier if you write them as inequalities. For example, let's do this example and see what they're talking about. So, given the function y equals to x squared, where x is bigger or equal to 0, basically what we were just talking about, write down the range of f. So we saw the sketch is like this. We see that the y's exist from here up until going up. So down here there's no graph. So it only works from 0 till infinity. So as you can see, y is bigger or greater than 0. Y is greater or equal to 0. Then B, that's it for the first one. Then B, determine the equation of the inverse of f. Again, this is the same thing. It's just that now, because of this restriction, at the end you're going to do something. So let's see what. So you still start the same way. Then you swap x and y for the inverse. Then you make y sub the formula. That is, you take that. Now, when you swapped the x and y, you also, the original came with this restriction. Then you swapped x and y, that means here you're gonna put y now. So you put y, that's the restriction for the inverse. So this was the domain, basically the restriction we got. This is the range for the original. So when you swap x and y, you also do that on here as well. Here it was x for the range, now it becomes x. It becomes the domain for the original. Now, so this the restriction says that y is bigger or equal to 0. That means we have to choose. We have plus minus. We have to choose the positive one. So since that's the case, you're gonna take the positive one. Therefore, the inverse will only be the positive one. and we have a note there. It is not necessary to write the x bigger or equal to 0. Exactly this part. It's not necessary to write it. It's only these two that are important. Then the other one is not necessarily important because it is implied by the square root. C. Again, we saw that the original was like that, that, and that. And joined the points. Now, for the inverse, you just swap the points. 0 is to 0. The point for 0 is to 0 will still be there. Will still be where 0 is to 0 is. And then the 1 is to 1 will still be where the 1 is to 1 is. But then the 2 is to 4 will go to 4 is to 2. So this stays there, this stays there. Now this one will be 4 is to 2 now, so it'll be there. Then just join them like that. D. So D, that was C. D says G is the reflection of F in the y-axis. Determine the equation of G. Okay, remember for the y-axis, x goes to negative x. So where there was x, you put negative x. So that means the equation will be from y is equals to x squared. Then they'll go for the inverse. It will be y is equals to negative x squared, which is still, if you open two brackets, minus x, you'll see that it's still negative times negative positive, still x squared. So the equation for the inverse is still the x squared. We're still on A. Let's see on the solution. Again, you swap x and y. I mean, you put negative x where you see x because reflection in the y-axis. Then if you simplify it, it'll still be that, like I just explained there. But then another thing that changes is, forget about this too. You saw the equation came with this. So it also applies. Where we see x, we put negative x. So if you put negative x there, and then divide by negative 1 on both sides, the inequality sign changes direction. So that means now you're looking at x is less than or equal to 0. So now the restriction has changed. The equation stayed the same somehow, but then the restriction changed. D, the second one says determine the equation of the inverse of G. So now we take that G that we got previously, that is this. Remember what G is now. We're going to find the inverse of that. So to find the inverse of that, again, we take it exactly the way it is. Just put y there instead of G with its restriction. For now, let's forget about this ones. With its restriction. So inverse, we swap x and y there. Even here, it was x, we put y now. Then we make y sub the formula, there we get plus minus. But then from the restriction, y is less than or equal to 0. That means we're going to take the negative one. Because it's less than, that means we're taking where it's negative. And therefore, there's the inverse. Number 3, sketch G and its inverse on the new set of x's shows line of symmetry. Again, if I forget, line of symmetry is y equal to x. So number 3, you'll see that now G, so the equation of G there. Now again, it's a parabola, but then now we are looking on the left hand side. So the same way we did that one, it's a function like this, just that now the x is less than or equal to 0, so we're only focusing on this side. You just need to understand that before you go forward with it. And then you can use the same points that you have there. That means you can say, okay, let me use 0 to 0, negative 1 is to 1, and then maybe 2 is to negative 2. Let's say negative 2 and 4. So negative 2, negative 2 and 4 will be there. And then you can just solve the points. You'll see that basically there. So 0 is to 0, negative 1 and 1, negative 2 and 4. Solve them, you see you're going to have those. And the 0 is to 0 still there. Just check more examples. I'll stop there.